Hi, this is John Isles and welcome to Geometer's Paradise. Today we're looking at Unit 5, Lesson 5, proving the converse parallel transversal theorems. There are 4 of these and they mirror the parallel transversal theorems. We have converse corresponding angles, converse alternate interior angles, converse alternate exterior angles, and the converse consecutive interior angles theorems. All of them have the same structure. You have 2 lines cut by a transversal, you have the angles being congruent or supplementary, and the lines being parallel. In this lesson we are going to prove the latter 3, and we're going to discuss how the converse corresponding angles theorem is constructed. So let's do that first. Here we have the converse corresponding angles theorem. What we want to do is, first of all, this is actually called a postulate. We're calling a theorem for consistency in class, but it's actually a postulate because we don't prove it. Instead, we're going to build a drawing to show that it's true. So we start off with a line and a transversal line, and then I'm going to place a point down here. I'm going to do 2 circles. I'm going to take a circle from A to C and put it on A, and then I'm going to do that same circle, A to C, and I'm going to put it on D. Alright, what we're going to do next is, well, let's get some more screen space. I'm not sure that helped me any. Alright, we're going to do some intersections. I need to intersect here and here, and then I'm going to use my compass tool to take a measurement from C to E. Then I'm going to take this new circle and put it on F. You'll recall that what I'm doing here is a copy angle construction, and the resulting line down here from G to D is actually going to be parallel. What we know though right now is that angle CAE up here and angle FDG down here are congruent angles. For the sake of argument, let's measure it. Oops, that's the wrong one. So let's measure CAE. Alright, so it's 86.78 degrees. Then let's come down here and let's do the same thing. Okay, so we got 86.78. So we know that these 2 angles are congruent to one another. I'll put it over here. Oh, I can't grab it. Alright, let's use the mouse. There we go. Okay, so the next question is, are these lines really parallel? And what we're going to do to prove that they are is place points on either side of the transversal, and I'm going to draw perpendiculars to one of the 2 lines. We know that perpendicular lines are the shortest distance between points. So if the distance from this point to the opposite side is the same, then we win. We have perpendicular lines. This is an oversimplification of the proof for this, but it's the general idea. So we show it twice and then we go ahead and assume the case is true. We would have to do an inductive proof, I think, to finish this off. But basically, this case right here tells us that if we build congruent angles, corresponding angles, congruent, then the lines that go through their sides are going to be, their non-transversal sides are going to be parallel. Okay, so that takes care of this, and essentially we say that this is proven that A is parallel to B. Of course the pen's not going to work. 1 second. Alright. Oh jeez. There we go. We say that A is parallel to B by construction. Okay, and again, that's why this one isn't really called a theorem, it's called a postulate. Alright, let's have a look at the other ones which we can actually prove. Now here's the deal. Just like before, we are only allowed to use the converse corresponding angles theorem, the vertical angles theorem, and the linear pair theorem, which is in some books called the supplement theorem. This is actually an extension of the supplement theorem saying that linear pairs sum to 180 degrees. So this is a theorem that we made up for class. So what we have to do to prove the alternate interior angles theorem is we have to prove that angle 3 and angle 6 being congruent results in A and B being parallel. And the only way we can do that is if we use the converse corresponding angles theorem. What we do is we start off and we have angle 3 being congruent to angle 6. This is a given. All right. And that gives us our first connection to here. So what's going to happen next, so this is our given, we're going to go vertical angles to connect 3 to 2. And then 2 and 6 are corresponding angles that will end up congruent. And that means that A and B are parallel by the CCAT. So we say that angle 3 is congruent to angle 2 by the vertical angles theorem. And then that means that angle 2 is congruent to angle 6 by transitive property. Okay, so what we have now is we have these two angles which are corresponding angles congruent to one another. All right, and that means that A is parallel to B by the converse CAT theorem, the converse CAT. Now, in your homework assignment, you'll have to prove that 4 and 5 are also congruent, and you do it in the same pattern. You'll go vertical to angle 1, and then 1 and 5 will connect by the converse corresponding angles theorem to prove that A is parallel to B. All right, let's look at the converse alternate exterior angles theorem. Again, we're trying to show that A is parallel to B, but now we start off with angle 1 being congruent to angle 8. All right, now we know that these two are congruent to one another. What we need to do is get vertical angles. So we're going to map 1 to 4 by the vertical angles theorem, and then we're going to map 4 to 8, okay, using the transitive property, because remember, this is given. And once we know that 4 and 8 are congruent, we know that the lines are parallel by the converse AEAT. Well, I'm sorry, no, the converse CAT. Right, again, we only have these tools available: CCAT, VAT, LPT. All right, so let's begin. We start with the given. Angle 1 is congruent to angle 8. And then we connect angle 1 to angle 4 by the vertical angles theorem. And then angle 4 is congruent to angle 8 by the transitive property. And since 4 and 8 are corresponding angles, that means that A is parallel to B by the converse corresponding angles theorem. Almost the same proof as before. You'll also need to prove that 2 and 7 create parallel lines. Remember, this is the alternate exterior angles theorem, so we're proving 1 and 8 and 2 and 7 generate parallel lines. All right, let's do the converse consecutive interior angles theorem. This is the last of the bunch. What we want to do is we want to prove that these sum to 180. Okay, if we can do that, these need to be switched. All right, so this should say that angle 4 plus angle 6 is equal to 180. And then this should say that A is parallel to B. I'll make that change for tomorrow. All right, so what we need to do then is make some connections, because we have to get to the converse corresponding angles theorem. We need corresponding angles, and these are consecutive interior. The process is exactly the same, only this time, instead of going across vertically, we want to create corresponding angles, so we're going to have to bump up here to 2 using the linear pair theorem. Okay, so we start off with angle 4 plus angle 6 equals 180 by given. And then we say that angle 2 plus angle 4 is equal to 180. And this is by the linear pair theorem. Okay, now at this point we know that 2 and 6 are basically what we call supplementary to the same angle. See, there's a connection here between the 4s and the 180s. So 6 and 2 are supplementary to the same angle, and that means they're congruent. But the way you work this out on paper is to go ahead and substitute on the 180s. So it goes angle 4 plus angle 6 equals angle 2 plus angle 4 by substitution. I need to write slower. And then we can subtract out the 4s from both sides. So we get angle 6 equals angle 2 by subtraction. And then we go ahead and make it congruent. Definition of congruence. Alright, now angle 6 being congruent to angle 2, these are corresponding angles that are congruent. So we can claim that A is parallel to B by the converse CAT. And there you go. Those are your 4 proofs. Now on your homework you'll have to do 3 and 5. You do it the same way, but you'll either take 1 and 3 as a linear pair or 5 and 7 as a linear pair, and then that'll do the same job that we did here. Okay, and I'm pretty sure that was the last slide. Yep, so good luck on your homework, and this is the last lesson in the unit. So make sure that you are studying up for that assessment. There's going to be plenty of proofs for you to do on it. You need to make sure you're ready to go.